Greetings. Today we are going to go over the second half of the Chapter 2 lecture. I want everybody to keep in mind when you view each lecture from each chapter that I'm not going to be covering every single concept that's discussed in the textbook, but I will be hitting on the major points that I consider to be most important. So just bear that in mind as you are watching the various lectures throughout the course. So today we are going to talk about research methods within the field of psychology. And it's interesting to note that most of the research methods that we talk about that pertain to the field of psychology also pertain to the social sciences more broadly. The social sciences tend to rely on very similar research methods in a cross-disciplinary fashion. So I've titled this lecture, How Do We Know? An Overview of Research Methods, because it gets to the core of the theme of this segment of Chapter 1, which deals with the question of epistemology. And going back to the first lecture, you might recall our discussion of how psychology as a discipline was historically rooted from within the discipline of philosophy. And one of the major questions that philosophers have concerned themselves for thousands of years is the question of how do we know what's true and what isn't? How do we evaluate claims to truth? How do we evaluate claims to knowledge? So in this chapter, we're going to look at the ways in which social scientists go about evaluating theories and ideas within the social sciences, and more specifically, psychology. Also keep in mind that this is a very introductory level lecture on the topic. So each of the topics that we discussed today, very briefly, we could spend hours and hours discussing each one of them with concern to how to carry out their methodologies and the theories behind them, etc. So if you really want a more in-depth coverage of research methods within the social sciences, you'll probably have to take a research methods course, either at the undergraduate or the graduate level, because we really can't go into any level of extreme depth in an intro-level course. So with that disclaimer out of the way, we'll go ahead and continue our discussion of research methods. So I begin by looking at the fact that there are a lot of claims that you will hear about the mind in pop culture and within the media. Maybe you've heard of the Baby Einstein video series. It's not as popular as it used to be, and you'll find out why momentarily. But there was a claim that was made that watching these Baby Einstein videos or similar videos like it could somehow make your child more intelligent later in life, and that these sorts of videos like Baby Einstein, and you hear about things like the Mozart effect and all of these things that are purported to make your children smarter when they're older. You know, is there any truth to these sort of claims? Well, these sorts of video series have been evaluated experimentally. Particularly, I'm thinking of a research study that was conducted out of the University of Washington, if I remember correctly, where these sorts of claims were evaluated. And there was no evidence that having your children watch videos like Baby Einstein or other similar video series could make your child more intelligent later in life. So the intentions may be good behind these sorts of products, but hopefully after taking this course, when you see these sorts of claims and advertisements and in the popular media, you'll have a little bit more of a skeptical approach to these sorts of claims, and you might ask yourself the question, well, how did they determine that? What sort of research methodology did they use? Did they have a random sample of participants, for example? Did they use an experimental method? Perhaps they only used correlational methods. These are the sorts of questions that you might want to ask yourself when you're hearing about scientific claims in the media. And we hear these sorts of claims all the time. I think of whether or not you should drink a glass of wine a day debate, depending on which news article you read. It depends that it just seems to depend. You know, one day drinking a glass of wine every day is good for your heart. The next day it's not so great for you. So you want to look at the overall body of knowledge when it comes to a particular research question. You don't just want to focus on one study. So today we're going to talk about three broad types of research methods that are used to evaluate claims about human behavior and claims about the mind. But before we get to the three broad types of research methods that are usually used within the social sciences and within the discipline of psychology, let's compare the scientific method to some other ways of ascertaining knowledge. Perhaps the most popular way to gain knowledge in this world is to take the expert's word for it. And there's nothing necessarily wrong with this, because experts are experts for a reason. Apparently they have some sort of authority or expertise on the subject matter that they're speaking on. But when it comes to the scientific method, we can't just rely upon the word of someone we trust just because we trust them. How is it that they came to that knowledge? Is there something more than just their authority that backs up their claim to truth? So authority might be a perfectly useful way to gain knowledge in our everyday life, but when it comes to evaluating claims of truth scientifically, it's certainly not going to cut it. Similarly speaking, the tradition of or the method of tradition, or sometimes referred to as tenacity, is a similar sort of idea to the idea of authority, but this is just kind of the idea that, well, this is what we've always believed, and everybody sort of takes it for granted as being the truth. Just like people used to just assume that the sun revolved around the earth. It was a belief that was handed down that had a lot of tenacity, and also some degree of authority behind it with the backing of religious figures such as the Roman Catholic Church. But believing something just because we've always believed it, well, that's certainly not a scientific reason to agree with a claim to truth or to agree with a particular theory. We certainly need more than, well, this is just what we've always believed. And the next one, intuition, this is something that we also rely upon quite frequently in our interpersonal lives. Oftentimes when we meet a new person, we get a first impression about that person, and often that, sometimes not, but usually that first impression will be pretty trustworthy, and we usually go with our gut. And when you go with your gut, we might say that you're trusting your intuition. You just seem to get a feeling about certain people or certain things, and that you just feel like this is the truth, whatever this is. But your intuition, you don't know exactly why you're coming to this conclusion, but your intuition tells you that you're on the right track. And there's certainly nothing wrong with relying on your gut or your intuition in your interpersonal life, in your everyday life, but it's certainly not a worthwhile method when it comes to evaluating claims about the nature of reality, claims of scientific truth. We have to get away from relying on our intuition as well. The last method that I want to talk about in this slide is logic, sometimes referred to as reasoning. And when it comes to the four ways of answering questions listed on this slide, logic is the closest thing to the scientific method. It's not quite the scientific method, but logic or reasoning, this is the tool of the philosophers. And oftentimes you will see logic or reasoning represented in thought experiments that are often utilized within the discipline of philosophy. But the key point here is that in most cases, there are no data that are being collected and analyzed. There's not actual research happening. That usually this is within the realm of thought experiments, particularly when it pertains to the discipline of philosophy. Not always, but that's often the case. So logic, although respectable and useful even within academic settings, is not even quite to the level that we need for a method of inquiry to be considered scientific. So what constitutes the scientific method? What distinguishes this method from those four methods that we just discussed? Well, here are some key elements that you can remember about the scientific method. For one, when science is conducted, ideally speaking, in most cases at least, the results of the research should be public, meaning that anybody can go out and witness the experiment or even conduct it themselves if they want to do what's called a replication. But you should be able to find out how the researchers did what they did, witness their results, or at least replicate them themselves, replicate them yourself rather. So there's this public aspect to science. There's also the sense in which, on a related note to it being public, there's an objectivity to the scientific method. Everybody should be able to look at what's going on and agree that this is actually what's happening, that we can all bear witness to the results that we're getting and agree that this is actually what's happening. And there's as little room for subjective interpretation of the results as possible. Ideally speaking, the more objective your measurements can be, the more scientific you are. When we say that the scientific method is empirical, what this means is that it relies upon the methods of the senses. So if it's information that can be detected by the sensory organs of your body, in terms of the data that are being collected, if it's empirical, that means that they are data that can be analyzed and witnessed through the five senses. Traditionally speaking, that's what we mean by empirical. When we say that science is systematic, that means that the scientific method is carried out in a controlled, rigorous way. Everything is planned out in advance. You're not flying by the seat of your pants, so to speak. There's a method to the madness, and there's a rigorousness to the way that the scientific method is carried out. Finally, we also say that the scientific method is cumulative and self-correcting. So what we mean by cumulative is that you look at the body of findings when it comes to a particular research question. We try to stay away from just judging reality by the results of one study. But if you have lots of studies that repeat the same pattern of results, then you say that you have a cumulative set of findings that you can rely upon. And the more cumulative your findings are, the more reliable, the more you can say that you're probably finding truth, so to speak. And we could debate the nature of truth philosophically, but the more results that you have to support your findings, the stronger your findings are. We also sometimes find within the field of science that we have to admit that we were wrong about something that we previously held as a scientific doctrine. And this is what we mean by self-correcting. Scientists have had to admit that they were wrong a number of times over the years. I'll give us a specific example of this momentarily. But when we're wrong, we admit that we're wrong, and we go wherever the data leads. So there is no, ultimately, our allegiance is to the data. As a famous mentor of mine in graduate school once said to me, show me the data. And if the data say that the truth lies elsewhere than what we previously believed, then that's the direction that we have to go. So the sciences are self-correcting. Finally, ultimately, the goal of understanding the world and the goal of having an idea of how the world works and what the truths about the real world are, the purpose of all of that is to be able to predict and control the world around us. Ultimately, all of this information would be of little use to us if we couldn't put it to use in a predictive manner. When I think prediction, I think of meteorology, for example, which is the science of trying to predict the weather. There would be no point in doing meteorology if we could not use those findings and that science in our everyday lives in some sort of way. And this applies to all the sciences, that we're trying to get an idea of how to predict the world around us more accurately and reliably. But in another sense, we're also trying to exercise some degree of control over that world as well by intervening and using the findings of science to make the world a more hospitable and comfortable place to live for human beings. So those are the key elements of the scientific method. A moment ago, I said that I would share an example of how the scientific method is self-correcting. And this is an example from within our own discipline of psychology, or more specifically from the discipline of neuroscience, which is intimately related to the field of psychology. For many years, within the field of neurology and within the field of neuroscience, there was a belief that once you had a fully biologically mature adult brain, by sometime around the early 20s, that the brain was essentially done developing for the most part, and that there weren't any new neurons that would come into existence within the brain or nervous system. And the neuron, of course, as we'll talk about later in the chapter on the brain, is the basic cell of the nervous system, fundamentally. But there was a belief that once you reached full biological maturity, that there were no new neurons that grew in the human brain. And in recent years, this is a doctrine that we've had to replace now with the knowledge that that there are new neurons that develop within the brain throughout the lifespan. Now, the number of them we're not exactly sure, but we know that within certain areas of the brain, like the hippocampus, for example, or the caudate nucleus, that there are at least a limited number of new neurons that spring into existence throughout the human lifespan. Sorry about that. So this is an example of how we often have to change our views when new evidence comes in. So science is self-correcting, and this is a fine example of that, and a recent one too, within the last couple of decades. So I mentioned a few minutes ago that we were going to talk about 3 broad types of research methods within psychology and the social sciences more broadly. And broadly speaking, there are 3 general categories of research that you will see in the social sciences: descriptive methods, correlational methods, and experimental methods. So today I'm just going to briefly talk about what those are so that you have at least a basic level understanding of these 3 types of research methods. So initially, descriptive methods simply describe what is occurring. Descriptive methods are not the most sophisticated level of analysis within science. It's often a starting point, a way of documenting something that's occurring in the world. For example, you might have an observational study. Let's say you have a preschool teacher or an elementary school teacher who wants to measure how many instances of aggression are occurring on average per day within that particular teacher's classroom, and which children are engaging in most of the aggressive behaviors. So you might conduct an observational study where the teacher would have a behaviorist come in and document all the instances of aggression and which children engaged in which aggressive behaviors at which times. And then you could plot that information on a graph over time, and this could give the teacher an idea of which one of her students were engaging in these behaviors most often, and how often the behaviors were occurring, what time of day, for example. So these data would be a useful starting point for understanding what's happening in that classroom. You certainly, with descriptive data, wouldn't be making any inferences about why this is happening. You're just simply observing things that are happening in the world around you without attempting to make any attributions as to the cause of those events. Another form of descriptive methods that you will sometimes see utilized in the social sciences are self-report data, where people fill out surveys and questionnaires reporting on their own behavior. Case studies are a more in-depth form of descriptive research. Often they take on the form of what's known as qualitative descriptive research, where the information that's yielded is non-numerical, where it's verbal information or written information about an in-depth case that a particular researcher is studying. Qualitative data is much more difficult to analyze statistically. However, qualitative data can often yield very rich, detailed information that you often can't get with numerical data. So many case studies you will see have this sort of qualitative flavor. And some researchers are very fond of using case studies, which are in-depth studies of one research participant. Sigmund Freud, for example, was particularly fond of the case study method. Almost all of his psychoanalytic work and theories were based upon the case studies of his own patients that he worked with. But what all of these descriptive methods have in common is that they're simply documenting something that's happening in the world, but usually there are not inferences being made about the causes of those events. It's just simply descriptive information, hence descriptive research. The next level of sophistication up, you might say the intermediate level of sophistication when it comes to social science research, is correlational research. So with correlational research, you're simply measuring relationships that exist between 2 variables. And when we use the term variable, what we mean is anything in the world that can be measured that changes. So anything that changes is considered a variable. So correlational research looks at how 2 or more variables are related to each other. And a vast amount of social science research is based upon correlational findings. Correlational findings have value. You'll often hear correlational research denigrated, but it is not useless research. It can definitely give you some clues about what's happening in the world. The problem with correlational research, however, actually, there's two problems with correlational research. You have the directionality problem, and you have the third variable problem. And it's these two problems, for these two reasons, you cannot make causal statements with correlational data. You can't make causal statements with descriptive data, and you cannot make causal statements with correlational data. And the reason why, two reasons why you can't make causal statements about correlational data are the directionality problem and the third variable problem. So let's say, for example, you look at the classic statistic, that's such a difficult word to say for so many of us, but there is a statistic that has been reported on where you will observe a positive correlation between the number of ice cream cones consumed, or we'll just say amount of ice cream in general. We'll say there's a positive correlation between the amount of ice cream that's being consumed by a given population and the number of shark attacks that occur within that given population. So that's a real correlation. You can look that up. And can we assume from that correlation that eating ice cream causes people to get attacked by sharks? Of course not. There's no real causal relationship between those two things, but they happen to be correlated with each other. As one goes up, the other tends to go up. And when you think about this for a moment, you can easily see why. People tend to eat more ice cream when it's warmer outside, right? And people also tend to go swimming at the beach more often when it's more warm outside during the summer. So people do both things more often when it's a hotter temperature. So the real reason why people are eating more ice cream is because it's hotter outside, and the reason why people are going swimming is because it's hotter outside. So that means that there's going to be a correlation between ice cream rate of ice cream consumption and the number of shark attacks that you see in a given population. So in this case, we have what's called a spurious correlation, because it's a real correlation that's been documented, but it's not really meaningful. And you can see these sorts of meaningless correlations throughout the literature. You can look up a number of them online. Just look up list of meaningless correlations, and I'm sure you'll find some if you Google it, and some of them are pretty funny. So when you have correlations, you got to be careful about making causal statements. You really shouldn't with correlational research, because there's always the possibility that you have a meaningless or spurious correlation. And in the case of the ice cream rate consumption and shark attack, that's an example of the third variable problem. So with the third variable problem, there's a third variable that's really responsible between the correlation, the two variables that are correlated. In this case, the third variable would be how hot it is outside. That's your third variable. Another problem with correlational research that prevents us from making causal statements is the directionality problem. And the directionality problem is often posed by philosophers as the chicken and the egg problem. It's the question of which came first, the chicken or the egg, right? And it's almost an impossible question to answer. And with correlational research, it's similarly impossible to tell which variable is responsible for the change in the other, if we even assume that there is a real causal relationship. So to give another example, let's say you do a study and you find that children who spend more time playing on their tablets or phones every night, you measure it, and you find that the more times children spend playing on their phones per day, the lower their GPAs in school, the lower their grades. So that would be a negative correlation. So the more time you spend on the phone, the lower your grades, right? Here we have a good example of the directionality problem, because it could be the case that all the time they're spending playing on their phone is causing them to not study and causing their grades to drop. Or it could be that they were just poor students to begin with, and they're just not very good students for whatever reason. And maybe kids who just aren't very good students like to play on their phones more than kids who are very good students. So you just don't know which variable is causing the change in the other. So the directionality problem and the third variable problem prevent us from making causal statements about correlations. With that said, a lot of social science research does rely upon correlational findings, and they're not necessarily always meaningless. Sometimes correlations can really cue you into something that needs further investigation. But if you really want to know that one variable is causing a change in the other, the only way that you can really do that is to conduct an experiment, which is the third type of research method that I want to briefly talk about today. So with the experimental method, what you have are two groups of people at minimum. You have what's called a control group and a treatment group. And the control group is given some sort of treatment, like a drug, for example, and the control group is not given the drug. They're given a sugar pill, and you look at how they change in some outcome. So a classic example of an experimental study would be your clinical trial that's conducted by pharmaceutical companies to test a new drug. Let's say you work for a pharmaceutical company and you want to test a new antidepressant. So the variable that we're interested in affecting is depression. So in this case, our dependent variable in this experiment would be the depression. So your dependent variable is the variable that you're trying to affect a change in. On the other hand, your independent variable is the treatment that you are administering that you are hoping is going to affect a change in the dependent variable. So in this case, we would operationally define depression. We might say if folks earn a certain score on a depression questionnaire, then they're categorized as depressed. So we would operationally define our terms. In this case, depression would be defined as a certain score on a depression questionnaire, and you would measure the effect of the drug on their depression levels. So the way it would work is you would give the treatment group the drug, and you would give the control group the fake drug. It would probably be a sugar pill, what's known as a placebo. And then several months later, you might follow up and retest them on their depression levels. And if you saw that the treatment group who received the new drug was significantly less depressed than the control group who had received the sugar pill, and you had conducted your experiment rigorously, then you might be able to say that your findings supported the idea that the drug is an effective treatment for depression. Now, on the other hand, if you don't really see any differences after treatment between the control group and the treatment group, then you don't have very good evidence that you've got an effective treatment for depression. So that would be an example, a classic example of an experiment. So you have your independent variable, which is your treatment. In this case, it would be whether or not you received the drug, and your dependent variable would be the outcome of depression and whether or not the drug had changed your depression levels. So your dependent variable would be depression levels in this particular scenario. So I talked about the control group and the experimental group. I just want to reiterate the meanings of those terms. So again, the control group is the group that does not receive the treatment. So in our particular example, our control group would be the group of people that receive the sugar pill. On the other hand, the folks who receive the real drug would constitute the experimental group. So in the experimental method, we want to make sure that we rule out the possibility that our results could be due to anything other than our treatment. So you have to exercise rigorous control over your procedures and methods when conducting an experiment. You don't want any outside variables to creep in that could possibly affect your results. And the possibility of that would be called confounding. So a confound is any possible variable that you might inadvertently allow to creep into your study that could invalidate your results. So for example, a confound that relates to the assignment, I apologize. A possible confound in experiment relates to your sampling procedure. So going back to our example of the controlled clinical trial for an antidepressant, let's say hypothetically that we assigned all the least depressed people, all the mildly depressed people to the treatment group, and the more severely depressed people to the control group. So that would mean that the less depressed people would be getting the new drug, and the more severely depressed people would be getting your sugar pill or placebo. Now, why would this be a problem for our results? Well, it's entirely possible that the less severely depressed people are going to get better anyway, right? It's the severely depressed people that are probably going to be more difficult to treat. So if we give the severely depressed people a fake drug, of course they're going to be less likely to show positive changes, because they're not even getting the real drug, and they're more severely depressed in the first place. So this would be a real problem. So to avoid this sort of confounding with regards to sampling, what we would utilize is a random assignment procedure. So we would make sure that both the treatment group and the control group are similar in terms of their participants, so that this sort of thing couldn't happen. And another thing that we might utilize is a double-blind procedure, which isn't listed on this slide, but a double-blind procedure means that the person who's receiving the pill, they don't know whether they're getting the real drug or the placebo. They don't know if they're in the treatment group or the control group. And also the person handing them the pill doesn't know whether they're handing the person the fake drug or the real drug. So both the person handing out the drug and the person receiving the drug, neither one of them know whether that's the real drug or the sugar pill that's being handed over. The pill would probably just have a little barcode on it or code that would be entered that would signify which one it was, so that the person analyzing the results would know, but the person handing out the drug would not know. That way it would not bias them, and the person receiving the drug wouldn't know for sure which drug, whether they were getting the real deal or not. So that would eliminate the possibility of confounding in that way. So double-blind procedures, random assignment, these are just a couple of ways that we can help ensure that confounding doesn't enter into our experimental procedures. And there are a lot of other experimental controls that you will learn about if you ever go on to take any more advanced training in research methods, particularly at the graduate level. But for the purposes of this course, what you guys need to know are the basic idea between the three major types of research methods: descriptive methods, which simply describe observations from the world; correlational methods, which describe relationships between two or more variables; and the experimental method, which is the only method, when done correctly, which allows a researcher to say that a variable has effected a change in another variable. So you need to know the difference between those broad types of research methods. The last thing that I want to talk about before we close this lecture are the ethical issues that are sometimes involved in conducting research. So the first thing that you want to concern yourself with when you conduct research is that your research has been cleared by an institutional review board, which is often referred to as an IRB. The IRB is the ethics board that's made up of a diverse body of decision makers who approve a given research proposal ethically before it's carried out, to make sure that it meets the standards that we're talking about in this slide. So the things that an institutional review board are going to be concerned about are listed in this slide. So first, they want to make sure that you're protecting the privacy of your research participants. You're not letting the results publicly be known in terms of the responses of any one participant. Of course, when you publish your research findings, the public will be privy to your general pattern of results, but they won't know the specific information that any one particular participant provides. And most likely that information will be conducted anonymously to even further protect that privacy. But protecting the privacy of research participants is extremely important, and confidentiality relates to this as well. So there's a subtle difference between privacy and confidentiality. So privacy is protecting the individual information provided by each research participant. On the other hand, confidentiality is not broadcasting the fact that someone has even participated in your study. So to give a concrete example of this, I'll go to my graduate master's thesis that I conducted at the University of West Florida for my master's in psychology, which involved having research participants fill out a series of questionnaires with regards to their religious affiliation and their sexual behavior patterns. I was interested in the relationship between religiosity and sexual behavior and sexual attitudes. So my participants filled out a battery of surveys with questions about their religious background, their religious beliefs, level of religious commitment, and they filled out questions regarding their attitudes with regards to human sexuality and their self-reported sexual behavior patterns over the last year when they filled out the survey. So privacy means that I would not let any one particular participant's information be shared. So you couldn't come to me and say, hey, I think John Smith participated in your thesis. I want to know, what John Smith's, how many people John's been with in his life, right? Because that was in your survey. So let's say his ex-girlfriend or his girlfriend comes and says, I want to know what John said on his human sexuality survey, something like that. Well, I certainly couldn't share that information with anyone. That would be a gross violation of a participant's privacy. Confidentiality is not even acknowledging in the first place that that person participated in my study at all. So for example, not only could I not share that person's specific information that they provided, but I also couldn't even admit in the first place that that person had even participated in my study. And that would be protecting the person's confidentiality. So hopefully you can understand the subtle difference between those two things. They're very related terms, but slightly nuanced in their meanings. Informed consent is the idea that your research participants know what they're getting into and that they're fully informed of the nature of the study that they're participating in, and they you provide them information about the nature of the study, and they sign off. Usually they'll sign and date an informed consent form that says, I've been fully made aware of the nature of the study, and consent means that they're welcome to participate or not participate, so you can't coerce someone into participating in your research. And they're also free to discontinue their participation in your research at any time. So they have provided informed consent. They've consented to participate in your research after being informed of the nature of the research. So this brings us to the next related point of deception. So in almost all cases, when conducting research with human participants, you would usually tell them exactly what you're studying, and there would be no surprises. There are some circumstances, however, in which research participants won't be honest with their responses if they knew exactly the nature of the research. You actually see a lot of this in some of the classic social psychology research, like the Milgram shock experiment, for example, which we'll explore in that chapter. But there have been a number of studies over the years where they've had to utilize a little bit of deception when they provide informed consent to the participants, or rather when the participants provide informed consent. Because if the participants knew what the study was really about, they would artificially change their behavior, and then you would have a confound that would result from that. It would invalidate the results of the study. So when that happens, occasionally an IRB will approve the use of deception in an experiment where you do deceive your participants a little bit to keep them from behaving artificially, basically to keep them behaving naturally. However, when this happens, the requirement is that when the study is over, you fully debrief your participants and tell them what the experiment was actually about after they've provided the data. So the use of deception in research is tricky. It has to be approved by an ethics board. It is sometimes permissible, but usually ethics boards are pretty stringent about this, and you'll probably have to argue your case to convince the ethics board that your use of deception is justified. So they're usually pretty cautious about that sort of thing when approving research. Finally, you want to make sure that the risk to your participants is not undue, that the benefits of conducting the research outweigh any particular risk to participants. So if you're just filling out a survey, usually it's relatively low risk. But if you're participating in a pharmaceutical trial where you're trying some new drug, where you don't know how this chemical is going to affect your body, risk to participants can become more of a sticky issue with that sort of thing. So it really depends on the nature of the research that you're conducting, just how big of an issue this is going to be. But that sort of thing is always decided by the ethics board, and they will approve your research or not accordingly. So that's what I want you guys to be familiar with from this second half of chapter 1. I want you guys to be familiar with the basic idea of the scientific method and how to distinguish it from other types of knowledge. I want you guys to know the 3 basic types of research: correlational, descriptive, and experimental. And I want you guys to be familiar with the basic principles of research ethics that we've talked about today. So that'll be it for Chapter 1. Our next lecture in Chapter 2 will cover the topic of the human brain. I'm very excited to talk about that next time, and I will see you guys then.